Hello friends, welcome back to Learning Nails and Aesthetics. Don't forget to comment, like, share, and subscribe. This is the Milady Foundation's Chapter 7, Electricity and Electrical Safety Summary. This series of videos, I forgot to say, I am not AI, so mistakes will be made. You can just laugh along with me. Okay. This series of videos highlights the major point of each chapter in the Milady Standard Foundations book. If you have not read the book or watched the videos of me reading it in its entirety, you should do so and consider this as a basic introduction. If you have read it, this is a good reminder of its contents. This is not a substitute for the entire book. I will not be flipping through the pages as I have painstakingly compiled the information. That being said, let's get started. Electricity is the movement of electrons from one atom to another along a conductor. Electricity is a form of energy that, when in motion, exhibits magnetic, chemical, or thermal effects. An electric current is the flow of electricity along a conductor. All materials can be classified as conductors or non-conductors depending on the ease with which an electric current can be transmitted through them. A conductor is a material that conducts electricity. Most metals are good conductors. This means that electricity will pass through the material easily. Copper is a particularly good conductor and is used in electric wiring and electric motors. Pure distilled water is a poor conductor. But the ions usually found in ordinary water, such as tap water or a river or lake, make a good conductor. This explains why you should not swim in a lake during an electrical storm. A non-conductor, also known as an insulator, is a material that does not transmit electricity. Rubber, silk, wood, glass, and cement are good insulators. Electric wires are composed of twisted metal threads covered with a rubber or plastic coating. A complete electric circuit is the path that negative and positive electric currents take from the generating source through the conductors and back to the generating source. Direct current, abbreviated as DC, is a consistent, even-flowing current that travels in one direction only and is produced by chemical means. Flashlights, cell phones, and cordless tools use the direct current produced by batteries. An inverter is an apparatus that changes direct current to alternating current. Inverters usually have a plug and a cord. The phone charger in a car is an example of an inverter. Alternating current, abbreviated as AC, is a rapid and interrupted current flowing first in one direction and then in the opposite direction. It is produced by mechanical means and changes direction 60 times per second. Corded blow dryers, curling irons, electric files, and table lamps that plug into a wall outlet use alternating current. A rectifier is an apparatus that changes alternating current to direct current. Cordless electric clippers and phone chargers use a rectifier to change the AC from an electric wall outlet to the DC needed to recharge their batteries. A volt, abbreviated as V and also known as voltage, is the unit that measures the pressure to force that pushes electric current forward through a conductor. Car batteries are 12 volts. Normal electric wall sockets that power your tools are 120 volts. Most air conditioners and clothes dryers run on 240 volts. A higher voltage indicates more power. An ampere, abbreviated as A and also known as an amp, is the unit that measures the strength of an electric current. Just as a hose must be large enough to carry the amount of water flowing through it, a wire must be large enough to carry the amount of electricity or amps flowing through it. A blow dryer rated at 12 amps must have a cord that is twice as thick as one rated for 6 amps. Otherwise, the cord might overheat and start a fire. A higher amp rating indicates a greater number of electrons and a stronger current. A milliampere, abbreviated as lowercase m and a capital A, is 1/1000th of an ampere. The current used for a facial and scalp treatment is measured in milliamperes. An ampere current would be much too strong if used for facials and scalp treatments, and an ampere current would damage the skin or body. An ohm, abbreviated as O, is a unit that measures the resistance of an electric current. Current will not flow through a conductor unless the force, which is volts, is stronger than the resistance, which is ohms. A watt, abbreviated as W, is a unit that measures how much electric energy is being used in 1 second. A 40-watt bulb uses 40 watts of energy per second. A kilowatt, abbreviated as lowercase k and lowercase w, is 1,000 watts. The electricity in your house is measured in kilowatts per hour, which is abbreviated lowercase kwh. A 1,000 watt, which is 1 kilowatt, a 1,000 watt, which is 1 kilowatt, a blow dryer uses 1,000 watts of energy per second. Practice electrical equipment safety. A fuse prevents excessive current from passing through a circuit. It is designed to blow out or melt when the wire becomes too hot from overloading the current with too much current, such as when faulty equipment or too many appliances are connected to an electrical source. To re-establish the current, disconnect the appliance, check all connections and insulation, insert a new fuse, then connect the appliance. Fuses are often found in older buildings that have not been renovated or modernized. A circuit breaker is a switch that automatically interrupts or shuts off an electric current at the first indication of an overload. Circuit breakers have replaced fuses in modern electric current circuits. They have all the safety features of a fuse, but do not require replacement and can simply be reset by switching the circuit breaker back on. A blow dryer has a circuit breaker located in the electric plug that is designed to protect both professional and client in case of an overload or short circuit. When a circuit breaker shuts off, you should disconnect the appliance and check all connections and insulation before resetting it. Grounding completes an electric circuit and carries the current safely away. All electrical appliances must have at least 2 rectangular electrical connections or prongs on the plug. The 2 prongs supply electric current to the circuit. For added protection, some appliances, especially ones with metal castings, have a 3rd circular electric connection that is a grounding pin. The grounding pin is designed to guarantee a safe path for electricity and protect the user from electrical shock even if the wire comes loose. A ground fault circuit interrupter, a GFI, which they used to be called GFCIs, is designed to protect from an electrical shock by interrupting a household circuit when there's a leak in the circuit. GFIs are required by the electrical code for receptacles in bathrooms, kitchens, and some outside receptacles. A GFI is designed to detect currents of a few milliamperes and trip a breaker at the receptacle or at the breaker panel to avoid a shock hazard. When it is working properly, a GFI has a green light and turns red when it trips. Once the appliance is removed from the socket, it can be reset with the reset button on the panel. Underwriter Laboratories, UL, certifies the safety of electrical appliances. This certifies that they are safe when used according to the manufacturer's directions. Always look for the URL symbol on electric appliances and take the time to read and follow the manufacturer's directions. Always register electrical appliances with the manufacturer so that you will be notified of any safety recall immediately. Disconnect all appliances when not in use. Pull the plug, not the cord, to disconnect it. Disconnect all electrical appliances prior to cleaning them. Never poke hairpins or wires through any part of an appliance, including lint screens. Inspect all electrical equipment regularly. Keep all wires, plugs, and electrical equipment in good repair. Do not use cords that have exposed wiring in any part of the cord or where it attaches to the appliance. Use only one plug in each outlet. Overloading may cause the circuit breaker to pop. If more than one plug is needed in an area, use a power strip with a surge protector. Avoid contact for both you and your client with water and metal surfaces when using electricity, and do not handle electrical equipment with wet hands or while standing on a wet floor. Keep electrical cords off the floor and away from everyone's feet. Getting tangled in a cord could cause you and your client to trip. Do not leave your client unattended while the client is connected to an electrical device. Do not attempt to clean around electrical outlets while equipment is plugged in. Do not touch two metal objects at the same time if either is connected to an electrical current. Do not step on or place objects on electrical cords. Do not allow electrical cords to become twisted. This can cause a short circuit. Do not alter a 3-prong plug to fit into a 2-prong outlet. Do not attempt to repair electrical appliances. If you have a problem with an electric wiring or an electrical device or appliance, tell your supervisor immediately. Take the device to a repair store or call a certified electrician or repair representative to resolve the issue. If you see sparks when plugging or unplugging an appliance, do not use the appliance or outlet until it has been approved by a certified electrician as safe to use. Verify regularly that fire extinguishers are appropriate for electrical fires, are not expired, and that you are comfortable with using one. Remove lint from clothes dryers before each load to reduce the chance of fire. If you receive a light shock sensation while using, turning on or off, or plugging or unplugging an electrical appliance, stop using the appliance immediately and turn it completely off. Unplug it from the wall or turn off the circuit breaker to that outlet. Replace the appliance or have it repaired by an authorized repair representative. If similar issues occur with other appliances in the same outlet, discontinue use of that outlet until approved for use by a certified electrician. If you drop an electrical appliance in water, if the outlet is GFI protected, it will kill the circuit immediately, and you may unplug the appliance from the wall. After releasing the appliance, do not have one hand in the water and one on the outlet. If the outlet is still live, your body will conduct the electricity. If the outlet is not GFI protected, go to the breaker box and flip the circuit off. If you are unsure which circuit controls that outlet, it is better to momentarily shut off power to the entire shop while you fix the situation. Once the power is off, unplug the item and then restore power. Never use an appliance that has been dropped in water. If you receive an electric shock, seek medical attention. Anytime during pregnancy, if you have burns on the skin, particularly those that are open or do not heal well over time, if you are not current on your tetanus immunizations, which are given every 5 years to adults. Identify electrotherapy modalities. The use of electrical current to treat the skin is commonly referred to as electrotherapy. Currents used in electrical facial and scalp treatments are called modalities, which produce a different effect on the skin. An electrode, also known as a probe, is an applicator for directing electric current from an electrotherapy device to the client's skin. It is usually made of carbon, glass, or metal. Each modality requires 2 electrodes, one negative and one positive, to conduct the flow of electricity through the body. The only exception to this rule is the Tesla high-frequency current, which uses a single electrode. Polarity refers to the poles of an electric current, either positive or negative. The electrodes on any electrotherapy device have a negatively charged pole and one positively charged pole. The positive electrode is called an anode. The anode is usually red and is marked with a P or a plus sign. The negative electrode is called a cathode. It is usually black and is marked with an N or a minus sign. The negatively charged electrons from the cathode flow to the positively charged anode. If the electrodes are not marked, ask your instructor, manager, or supervisor to help you determine the positive and negative poles. The main modalities used in beauty and wellness services are galvanic current, microcurrent, and Tesla high-frequency current. Galvanic current is a consistent and direct current having a positive and negative pole that produces chemical changes when it passes through the tissue and fluids of the body. 2 different chemical reactions are possible with galvanic current depending on the polarity, which is the positive or negative. The active electrode is the electrode used on the area to be treated. The inactive electrode is the opposite pole from the active electrode. The effects produced by the positive pole are the exact opposite of those produced by the negative pole. Galvanic current is used to infuse water-soluble products into unbroken skin. The scientific term for this is phoresis. Ionphoresis is the process of infusing water-soluble products into the skin with the use of electric current, such as the use of the positive and negative poles of a galvanic machine. Cataphoresis infuses an acidic, positive product into deeper tissue using a galvanic current from the positive pole towards the negative pole. Anaphoresis infuses an alkaline, negative product into the tissue from the negative pole towards the positive pole. Disincrustation, a form of anaphoresis, is a process used to soften and emulsify grease deposits and blackheads on the hair follicles. Disincrustation is frequently used to treat acne, milia, and comedones. Microcurrent is an extremely low level of electricity that mirrors the body's natural electrical impulses. Microcurrent can be used for iontophoresis, firming, toning, and soothing skin. It also can help heal inflamed tissues such as acne. Newer microcurrent devices have negative and positive polarity in one probe, not 2 probes. This allows the client to relax rather than having to hold onto a probe during the service or treatment. Microcurrent does not travel throughout the entire body. It serves only the specific area being treated. Microcurrent can be effective in the following ways: improves blood and lymph circulation, produces acidic and alkaline reactions, opens and closes hair follicles and pores, increases muscle tone, restores elasticity, reduces redness and inflammation, minimizes healing time for acne lesions, improves the natural protective barrier of the skin, and increases metabolism. As with all electric current devices, microcurrent should not be used on clients who have a pacemaker, epilepsy, cancer, phlebitis, or thrombosis, or who are pregnant. It also should not be used on anyone under a physician's care for a condition that may exclude them from using certain ingredients or products or from having treatments. If you are unsure about whether it is appropriate to treat clients, ask them to obtain a physician's consent for the service. The electromagnetic spectrum, also known as electromagnetic spectrum of radiation, is a name given to all the forms of energy or radiation that exist. The forms of energy in the electromagnetic spectrum are radio waves, used by radios and television, microwaves, used by microwave ovens, light waves, infrared light, visible light, and ultraviolet light, used for light therapy services, X-rays, used by physicians and dentists, and gamma rays, used by nuclear power plants. Energy moves through space in waves. These waves are similar to the waves caused when a stone is dropped on the surface of water. Each type of energy has its own wavelength, the distance between successive peaks of electromagnetic waves. A waveform is the measurement of the distance between two wavelengths. Some wavelengths are strong and some are short. Long wavelengths have low frequency, meaning that the number of waves is less frequent, fewer waves, within a waveform pattern. Short wavelengths have a higher frequency because the number of waves is more frequent, more waves, within a waveform pattern. Visible light is the part of the electromagnetic spectrum that can be seen within the visible spectrum of light. Violet has the shortest wavelength, and red has the longest. Wavelengths of light are measured in nanometers, abbreviated lowercase nm. 1 nanometer is a billionth of a meter. Visible light has wavelengths ranging from 400 nanometers to 700 nanometers. Although they are referred to as light, infrared light and ultraviolet light are not really light. Ultraviolet light and infrared light are also forms of electromagnetic energy, but are invisible because their wavelengths are beyond the visible spectrum of light. Invisible light makes up 65% of natural sunlight. Invisible light is the light at either end of the visible spectrum of light that is invisible to the naked eye. Before the visible violet light of the spectrum is ultraviolet light. It is the shortest and least penetrating light of the spectrum. Beyond the visible red light of the spectrum is infrared light, which produces heat. Ultraviolet light, abbreviated UV light, and also known as cold light or actinic light, is invisible light that has a short wavelength, giving it higher energy, is less penetrating than visible light, causes chemical reactions to happen more quickly than visible light, produces less heat than visible light, and kills some germs. UV light prompts the skin to produce vitamin D. a fat-soluble vitamin that is good for bone growth and health. Ultraviolet A, UVA. Ultraviolet A light has the longest wavelength in the UV light spectrum and penetrates directly into the dermis of the skin, damaging the collagen and elastin. UVA light is the light that is often used in tanning beds. UVB, which is ultraviolet B light, is often called the burning light because it is most associated with sunburns. Excessive use of both UVA and UVB light can cause skin cancers. Ultraviolet C, UVC, is blocked by the ozone layer. If the Earth loses its protective layer of ozone, life as we know it will no longer exist. UVC is effective at killing bacteria, viruses, mold, and other pathogens. Infrared light has longer wavelengths, penetrates more deeply, has less energy, and produces more heat than visible light. Infrared light has been used to diminish signs of aging, such as wrinkles, to heal wounds, and to increase circulation. Catalysts are substances that speed up chemical reactions by using heat as the energy source, while others use light. Whatever the energy source, catalysts absorb energy like a battery. At the appropriate time, they pass this energy to the initiator, and the reaction begins. Like other chemicals, a catalyst will not be consumed in a chemical reaction. In acrylic nails, the monomers used are the catalysts that solidify the nails. In the application of gel nails, the UV light is the catalyst for hardening. Light therapy, also known as phototherapy, is the application of light to the skin for the treatment of wrinkles, capillaries, or pigmentation for hair removal. Lasers and light therapy devices have been used for decades. Lasers are designed to focus all light power to a specific depth and in one direction within the skin. Using the same color of light in contrast with other light therapies have multiple depths, colors, and wavelengths, and the light may be scattered. So again, to reiterate, this series of video highlights the major points of each chapter of the Milady Standards Foundation book. This was Chapter 7, Electricity and Electrical Safety. If you have not read the book or watched the video of me reading it in its entirety, you should do so and consider this as a basic introduction. If you have read it or watched my videos, this is a good reminder of its contents. It is not a substitute for the entire book. That being said, I appreciate you watching. I hope this was helpful to you. Don't forget to check out my other videos and comment, like, share, and subscribe. And have a great day. Thanks. Bye.